Hi, everybody. This is Junjie. I hope you're doing great and stay safe. My topic is a thorough comparison of the data lake, Iceberg, and Hudi. I'm a software engineer working at Tencent Data Lake team. So I've been focused on big data area for years. Yeah, this is today's agenda. So firstly, I will introduce the data lake, Iceberg, and Hudi a little bit, and then we'll deep dive to the key features comparison one by one, and then we'll have talk a little bit about the project maturity, and then we'll have a conclusion based on the comparison. So as we know, data lake conception have been come out for a long time. So what features are we expect for the data lake? I did some investigation and summarize some of them listed here. So firstly, I think transaction or ACID ability of the data lake is the most expected feature. So with the transaction feature, a data lake could enable advanced features like time travel, concurrent read and write. Secondary, definitely I think is support both batch and streaming. And since streaming workload usually allow the data to arrive later, so we also expect the data lake have features like data mutation or data correction, which could allow the late arrived data to merge into the base data set and correct the base data set to for the business view or the report for the end user. Also, as the table may changes around with the business over time, so we also expect the data lake to have features like schema evolution and schema enforcement, which could update schema around over time, and then we could use the schema enforcement to protect prevent the low quality data from data ingesting. Also, we hope the data lake is independent of the engines, and the underlying storage is pluggable as well, so that data could store in different storage model like AWS S3 or HDFS. And more engines like Hive or Presto and Spark could access the data. So last and not least, we also hope the data lake have a scalable metadata module, which could store the billions of partitions and files for a table. So the projects data lake, Iceberg, and Hudi are providing these features to a data lake. So let's take a look at them. So data lake. So data lake is an open source storage layer that brings ACID transaction to Apache Spark and the big data workloads. So from its architecture picture, we could see that it has at least 4 of the capability we just mentioned, like support both streaming and batch. It has a schema enforcement to prevent low quality data, and it also has a good abstraction on storage layer to allow more various storage storage layer storage, and it also has the transaction feature, right? Yeah, Iceberg is origin from the Netflix. It has been donated to the Apache Foundation about 2 years. So like Delta, it also has the mentioned features. So Hudi is yet another data lake and storage layer that focuses more on the streaming processing. As you can see in the architecture picture, it has a built-in streaming support service to handle the streaming things. So here's a quick comparison. So as you can see in the table, all of all of these projects have the same very similar feature in like transaction, multi-version, MVCC, time travel, etc. So some of them may not have haven't been implemented yet, but I think they are more or less on the roadmap. However, the details behind these features is different from each to each. I think understand the details could help us to build a data lake match our business better. So let's take a look at the feature difference. So firstly, transaction. So data lake has a transaction model based on the transaction log or delta log. So it logs the file operations in JSON file and then commit to the table, use the atomic operations. The isolation level of the delta lake is write serialization, which means it allows a reader and a writer to access the table in parallel. Well, if there are two writers try to write data to table in parallel, then each of them will assume the there's no changes on the base table. Then it will then before commit it will check that if there's any changes to the latest table. Then if there's any changes, it will retry the commit. So Delta Lake has an optimization on the commit. It will checkpoint each 10 commit into each 10 commit, which means each 10 JSON file into Packet file, so as to improve the read performance. The atomicity is guaranteed by HDF's rename or S3 file write or assume rename without overwrite. So user with the Delta Lake transaction feature, user could do the time travel query according to the timestamp or version number. For Iceberg transaction model is snapshot based. A snapshot is a complete list of the file in table. The table state is maintained in metadata files. All changes to the table state create a new metadata file and replace the old metadata file with atomic swap. So like Delta Lake, it applies the optimistic concurrency control. And user could able to do the time travel queries according to the snapshot ID and timestamp. So Hudi's transaction model is based on the timeline. A timeline contains all actions performed on the table at different instants of the time. The timeline could provide instantaneous views of the table and support get data in the order of the arrival. It also applies the optimistic concurrency control for the read and write. So a user could also do the time travel according to the Hudi commit time. So next one, yeah, data mutation. So currently, both Delta Lake and Hudi support data mutation. While Iceberg haven't supported it, the community is working in progress. So Delta Lake's data mutation is based on copy on write model. Basically, it needs 4 steps to do the update. So first, it will find file according to the filter expression, and then it will load files as data frame and update the column values according to the while the logical frame transformation, and then it will save the data frames to new files. And finally, it will lock the files to delete and add it to the JSON file and commit to the table while the atomic operation. So Delta Lake provide a set of user-friendly table-level API like update and delete and merge into for the user. So I would say that Delta Lake data mutation feature is a production-ready feature. Well, since Hudi focuses more on the streaming processing, and because the latency is very sensitive to the streaming processing, so Hudi has two kinds of the upsert or data mutation model, both of the copy on write model and a merge on read model. When user perform the copy on write model, it basically the process is very similar to the data lake. It will read out the records and then update the records according to the provided updated records, and then it will write merge record to files and then commit to table. So since the latency is very important to data ingesting for the streaming process, so Hudi provide indexing to reduce the latency of the for the copy on write step 1. It will provide an indexing mechanism that mapping the Hudi record key to the file group and IDs, so that the file lookup will be very quickly. So currently it supports 3 types of the index: in-memory, Broom filter, and HBase. So when the data ingesting when people cache the latency most for the data ingesting, they can apply the merge on read table, and the Hudi will store the delta logs in delta records into arrow format in log file, and then it will a subsequent reader will fill out the deleted records according to those log files. It also will schedule the period compaction to compact arrow files to Apache to accelerate the read performance for the later access. So Hudi provide table level API upsert for the user to do the data mutation. Well, as for Iceberg, currently Iceberg provide a file level API named override. User could use this API to build their own data mutation feature for the copy on write model. The community is focused more on the merge on read model. The design is ready, and basically it will store the row identity of the record to delete into the precision-based delete file and the equality-based delete file. Then the afterward or subsequent reader can fill out records according to these files. Yeah, next is streaming spot. Yeah, there's no doubt that Delta Lake is deeply integrated with the Spark structure streaming. So it could serve as the streaming source and streaming sink for the Spark streaming structure streaming. The user could control the rate through the max bytes per trigger or max files per trigger. It also has some small limitation. Currently, it cannot handle the non-appended model. So as we mentioned before, Hudi has a built-in streaming service. So named Delta Streamer. It takes a responsibility for handling the streaming things, like it provides exact ones semantic for data ingesting, like Kafka, and it also supports JSON, Avro, or customized record types. It could manage the checkpoint, rollback, recovery, and also support for plugin transformation for data ingesting. So for the incremental queries or incremental scan, Hudi provide a utility named Hive incremental puller, which allows user to do the incremental scan while the Hive query language. Since Hudi implemented the Spark data source v1 interface, so user could also perform the incremental scan while the Spark data frame API with the option begin instant time. Well, Iceberg, since Iceberg doesn't bind to any streaming engines, so it could support a different type of the streaming. Currently, it already supports Spark structure streaming, and the community is built streaming support for the Flink as well. Yeah, another feature, important feature, schema evolution. So Delta Lake and Hudi, both of them use the Spark schema as its a table schema, and it allows the schema evolution will happen when the write client, write data, write insert data, or merge the data into a base table. If the incoming data has a new schema, then it will merge or overwrite according to the write options. Well, Iceberg handle the schema evolution in a different way. Since Iceberg has an independent schema abstraction layer, which is for the full schema evolution, which means you can update the table schema in place, and it also supports partition evolution, which is very important. Imagine that you have a data set that partition by day at the beginning, and as the business grows over time, you want to change the partition to finer granularity, such as hour or minute. Then you can update the partition spec through the partition evolution API provided by Iceberg. Yeah, so due to the time, so that's all the key feature comparison. So I'd like to talk a little about the project maturity. So firstly, the upstream and downstream integration. So Delta Lake implemented the data source v1 interface. So user could read and write data while the Spark data frame API. And also the Delta community is built a connector that could enable more engines to read data from table like Hive and Presto. So Iceberg, same as the Delta Lake, implemented the data source v2 interface from the Spark. It also increments the MapReduce input format and Hive storage handler. So basically, user could write data through the Spark data frame API or its Iceberg's native Java API, and then it could be read from any engines that support input format or Hive storage handler. And the community is also working on support the Flink sync as well. So Hudi, as I know, the Hudi implemented the Hive input format so that it could read through the Hive interface. It also implemented data source v1 of the Spark. So Hive could support write data through the Spark data source v1. So as well, besides the Spark data frame API to write data, Hudi has built, as we mentioned before, Hudi has a built-in Delta streamer service that used for data ingesting that could write streaming data into the Hudi table. So next, query performance. Yeah, since data lake is well integrated with the Spark, so it could enjoy or share the benefit of performance optimization from Spark, such as vectorization, data skipping values statistic from the packet. And data lake also builds some useful command like vacuum to clean up old data, and optimize command to use to compact the small files into a big file. That would mitigate the small file problems. So Hudi, since Hudi also bind route to the Spark, so it could also share the performance optimization. And Hudi also has a compaction functionality that could compact the delta logs, delta records into packet to accelerate the read performance for the merge on read table. As for Iceberg, since Iceberg does not bind to any specific engine, so it has some native optimization like predicate pushdown for the Spark data source v2, and it has vectorized the reader native vectorized reader, and it support Iceberg store the statistic into the metadata file so that it could it could help data skipping as well. So it was to mention that Iceberg has an advanced feature named hidden partition, which store the partition values into a metadata file instead of a file listing. We could fetch the partition information just using reader metadata file. So it will help to improve the job planning route. Yeah, the tooling, that's the tooling. Yeah. So as I know that, as we know, Delta Lake and the Hudi provide several command line tools like in Delta Lake's vacuum history generate convert to a set of utilities to operate directly on tables, and Hudi also provide auxiliary commands like inspecting, view statistic, and compaction that could manipulate directory on the tables. And well, Iceberg expose the metadata as tables so that user could query the metadata just like a SQL table. So Iceberg has a built-in catalog service, which is used to enable the DDL and DML support when integrated in with the Spark 3.0. So Hudi also has, as we mentioned, has a lot of utilities like Delta Streamer service and Hive incremental puller and Hudi Delta Streamer to support data ingesting and table upsert. So yeah, I think that's all for the maturity comparison. Yeah, so based on this comparison and the maturity, comparison, feature comparison and the maturity comparison, we could have a conclusion that Delta Lake has best investigation with the best integration with the Spark ecosystem and could be used out of box. And Iceberg has a great design and abstraction that could enable more potentials and extensions. And Hudi, I think it provides most of the convenience for the streaming process. Thank you very much. That's it. So any questions?